Human salmonellosis cases remain a prevalent issue within Ontario's food sector. Among the various transmission vehicles for salmonella, poultry has been linked to the highest cause of this foodborne illness within the province. Both retailers and the government are looking to reduce the prevalence of salmonella on eggs at both the hatchery and table level. Egg washing is currently mandated but has limited efficacy. To mitigate this, we investigated the application of advanced oxidation process technology to inactivate salmonella located on an egg's protective sites that are not accessible through standard washing currently practiced in the industry. Advanced oxidation process, or AOP, is known as the generation of hydroxyl radicals through the interaction of hydrogen peroxide, ozone, and UV light. These hydroxyl radicals act as sanitizing agents to disinfect the surface of the egg when introduced into the AOP reactor. The following methodology was executed to explore the efficacy of AOP disinfection of shelled eggs. Eggs were first inoculated with salmonella. The eggs were then placed in the AOP reactor and were exposed to various combinations of hydrogen peroxide concentrations, UV, and ozone doses to obtain the optimized treatment of salmonella disinfection. Bacteria recovery and plating steps were then executed to enumerate any surviving salmonella post-AOP treatment. Results were compared against untreated controls in order to validate the treatment. To assess the impact of the AOP technology on the quality of the egg samples were tested over a 35-day period to mimic the shelf life of the food product. Here, yolk color and the Howe unit were evaluated. To compare the efficacy of the industry's standard washing versus the AOP technology, a sodium hydroxide pre-wash and a hypochlorite post-wash were also observed. It was concluded that the optimal advanced oxidation process treatment to disinfect shelled eggs from salmonella consisted of a 5-second dose of UV and ozone with 2% hydrogen peroxide. Here the treatment was able to sustain a greater than 5 log per CFU reduction of the pathogen. Furthermore, the treatment did not demonstrate any negative effects on the quality or shelf life of the eggs. During comparison trials, it was determined that the industry's standard washing yields a lower reduction of the pathogen compared to the AOP treatment. Advanced oxidation process holds great significance as a novel technology in Ontario's food industry. By applying AOP in the egg processing industry, water consumption can be greatly reduced as the technology does not utilize any water. In addition, AOP technology can be further applied to disinfect other food commodities, surfaces, and holds potential to combat avian flu. To supplement this research and further combat the prevalence of salmonella in Ontario's poultry industry, trials investigating the application of the technology in hatchery eggs is currently in progress.